What's going on, guys? My name is Suboptimal and I'm just your typical Indian software engineer. In this game dev experiment, we'll go over the process of building a 3D audio waveform visualizer using React, the Web Audio API, and Three.js. Now, this is the third Three.js project that I'm making a video on, so I don't want to bog you guys down with all the details of setting up Next, Tailwind CSS, and Three.js. So I'm just going to sort of go through them pretty quickly. Now, if you want the full details, just go to the GameDex repository on my GitHub and you'll see everything there. The first thing we're going to want to do is set up Next and Tailwind. And the reason I like using Tailwind is just because I'm really bad at CSS and Tailwind makes me less bad at CSS. So we're going to run npx create next app with Tailwind CSS and specify a project name. Once you do that, you're going to get a project with, a bunch of like boilerplate code, and remove the entire default code. And all I do is create a canvas, and inside of the React component, I create a use effect, which is basically going to run after the canvas has been initialized inside of the DOM. So we're going to create a use effect and create a scene. So up until this point, all we're really doing is setting up Next, Tailwind, and Three.js. So the first thing I'm going to do is just create a simple plain geometry and add it to the test scene. So basically, all this is to say that I'm just setting up a basic Three.js project. So let's run the code and see what we get. So after running that set of code, we get a plane that looks like this. As you can see, it's basically just, 64 by 64, and it's got all the vertices, and it's got, orbit control so you can move it around. So the next step in this process is adding the audio to our web page so that we can get the audio data and send it into the Three.js plane and manipulate the plane based on the data. So the first thing I'm going to do is add a div at the bottom right of the page, and this is just going to include the audio. So as you can see here, I downloaded For Elise from Beethoven, and I create the ID of my audio, and on play I do a couple of things. Now the first thing that we do when we play is we set up the audio context. Now this is a way that you can get the frequency data from your audio that is playing on your web app. So we set up the context, we get the audio element, and then we basically run a bunch of code to set up the analyzer such that we can get the frequency data from the analyzer. And we create a new array, and basically this whole function is just used to get the audio information from the music player. And once it is set up, right, we want to update this array every time we render a new frame on the page, because as the audio is playing, we're going to keep getting more and more data, and we want to refresh that data. So here inside of the render function, I'm going to update the data array, and of course I'm going to run this render function on every animation frame. So let's take a quick little demo of that. So I'm going to start playing Beethoven here, and you're going to see the plane pop up as well as the data being displayed about the frequency information. As you can see, we got the plane, we got the data. Now the next step is to take this frequency information and pass it into this plane so that we can manipulate the way this plane looks based on the frequency information. If you guys remember from before, we created a plane geometry 64 by 64 and passed in a mesh normal material. But what we want to do is update that and use a shader material. And so a shader material is something that is going to allow you to control where the vertices on your plane are, as well as the color of those vertices and the pixels in between them. So basically, these two lines of code is where all the magic for this project is happening. And of course, I want to pass in a couple uniforms. Uniforms is just the data that you pass into the Vertex and Fragment shader. So for example, I'm going to pass in the data array, which is the frequency audio data that is going to constantly get updated every frame, as well as the time. I'm going to be using these two pieces of data, and I'm going to be manipulating the Vertex and Fragment shader based on these two pieces of data. So let's just start off simple and see what a basic Vertex shader would look like. A vertex shader is something that is written in GLSL, which stands for Graphics Library Shader Language. And basically this language looks kind of like C, but you don't have to really stress too much about it because we only care about one thing, and that thing is the GL position. So Vertex shaders have like these default variables that they can take in and that they need to pass back out. And one of those things is called the GL position, and that's just the position of a specific vertex. By default, the vertex shader is going to get some variables like the projection matrix and the model view matrix, but these two things are sort of unnecessary. Just sort of take them for what they are. The real thing that we care about is the position. So we can take the position, and right now the first vertex shader that I'm going to show you guys is just doing nothing, right? It's taking the X position and putting it in the X coordinate. It's taking the Y position, putting it in the Y coordinate, and doing the same thing for the Z position. So if we look at the resulting image, you'll notice that nothing actually changed. So let's take a look at the second vertex shader. Now the second vertex shader is going to be doing something a little more interesting. Now remember, in the first one, all we did was pass in the X, Y, and Z positions. And for the second one, what we're going to do is pass in the X and Y positions the same, but we're going to determine our own Z position. And the Z position is going to be based on the sum of the absolute values of the X and Y positions. And of course, you can see it in the background already what it is doing, right? We have a absolute value graph in 3 dimensions. So if you've ever seen those Y equals absolute value of X graphs, this is basically that type of graph, but in 3 dimensions. So now let's take a look at this third vertex shader. I'm just sort of additionally adding more and more things to it until we sort of see what is exactly possible, right? So before I just had the absolute positions, but now I'm going to take the sign of that and put that in the Z direction. So you can imagine it's going to be like a wavy type of thing. And let's see what it looks like. And as you can see, it looks, it's starting to look pretty cool. And now let's just do one final addition to this vertex shader. And I'm going to call this the fourth vertex shader. And now we're just going to be incorporating the time variable that we're passing in to the function. So if you guys remember, we're passing in some uniform data, and one of that pieces of data is the frequency array and the other is the time. So I'm just sort of showing this to you guys so you can see how you can sort of incrementally add stuff and understand how to change the vertices. So we had our same function as before, but this time we're going to add time to it. So that means it's going to start sort of this wavy motion. So let's see what this looks like. As you can see, it's starting to look pretty cool, right? Because now we are basing that value on the time. And finally, what I ended up doing was creating this vertex shader. Now, obviously, this is a lot more complex, but the core concept is still the same, right? This time, I'm actually using the information passed in from the data array, which I passed in as the u_data_array. That is a variable I passed in as a uniform, and so now we can sort of reference it, and I'm using it to update our z value. It took me like an hour or two to just come up with this. I was just sort of figuring out what numbers made it look good. So at the end of the day, this is what you get when you incorporate this vertex shader into your project. So the Fragment shader has a very similar format to the Vertex shader. It's also written in GLSL, and this time what we need to do is determine a frag color instead of a position. So the variable that the Fragment shader always looks for is GL_frag color. Here I'm passing in a vec4, which represents RGBA. So 1, 0, 0, that's basically the red color. So if we go back to our screen, you'll notice that we've got the red color up and going. Now let's take a look at one final Fragment shader, and this time we're going to be varying the colors based on the time, and you can sort of get a sense of what this is going to do, right? We know that sine is going to go between -1 and 1. So what we can do is oscillate based on the time and take the absolute value, because the values that the frag color expects are between 0 and 1. So we should oscillate between 0.0 and 1.0. We see here that every couple of seconds the plane is fading completely to black when the values are 0, 0, 0. and every once in a while there'll be 1, 0, 0, and that's when it's turning red. And it was in this process that I was able to come up with this fragment shader. So this fragment shader is a little bit more complex, but I sort of just, again, played around with the values until I found something that had this cool rainbow effect. It's just a little bit of math. And so putting the vertex and fragment shader together, we're going to get this. And of course, I added a couple other settings like displaying the wireframe and changing the amplitude, which I'll play around with in the demo at the end. So yeah, that's going to be it for today. Hopefully now you guys have a little bit of an understanding of how to build your very own audio wave visualizer with JavaScript. If you enjoyed the content, then be sure to leave a like on the video because that really does help me out, and consider subscribing for more suboptimal content just like this. Thanks for watching, and I'll catch you guys next time.